Do you need help in chemistry? Well, get ready to play your favorite game show. This game show is meant to help you, yes, you understand chemistry. Here's the game show. There's 3 questions. If you get all 3 right, we call you a brave scholar. If you get 2 right, you are a never scared student. So you kind of know yourself, or you know majority of it. If you get 1 right, well, y'all remember that show, Courage the Cowardly Dog? Well, that's you. You're kind of brave, but you're acting scary the entire time. Get to know your stuff. And if you don't get any right, well,
we have some explaining to do.
I'm your host, Dr. J, and let's play What Do You Know? So you're going to see that this is iron, and this is a metal, and then we have chlorine, which is a non-metal. Okay, so if you remember, right, a metal and a non-metal is an ionic compound. Okay, so ionic compound. So since we have an ionic compound here, how are we going to go about naming this? Okay, so in this case, with ionic compounds, we're following a set of rules. So the metal goes first, iron. All right, so I'm not going to change that. And then what do we do with our chlorine here, right? So we changed that chlorine. If you remember, you changed the ending for your nonmetals. Okay, that second word. So that second word, that chlorine, will be changed to chloride. Chloride. So now we have iron chloride. Now, are we done with naming this compound? No, we're not done. Okay, so we got to realize one more thing. This is a transition metal. Okay, so since iron can have multiple oxidation states, right, multiple charges, we need to realize, right, that a Roman numeral will go here. Okay, you cannot forget the Roman numeral. That's very important. If you don't have a Roman numeral, it's wrong. Okay, because like I said, there's multiple oxidation states. So in this case, well, Dr. J, I don't know the oxidation state. Do I have to go look at a periodic table to find that? No, you don't have to do that. Okay. So right now we're trying to determine what's the oxidation state, what's the charge of iron. So a big hint here is the chlorine. This is where I say y'all need to, if you know the chlorine, if you know your main group charges, this is going to make writing and naming the formulas a lot easier. So let's go over what exactly this is going to be. So chlorine. Chlorine is a halogen, right? So all halogens got similar properties. In this case, the charge for a halogen is actually -1. All right, -1 charge. So if you have a -1 charge, and we understand, right, after, if you guys check out that other video, check out that video when I'm talking about writing the chemical formula. So if you understand that for neutral compounds, you gotta equal 0. All right, it's a neutral compound. I know it's a neutral compound because I don't have any charges. I just wrote this one here to show you guys that chlorine has a -1 charge. But this is a neutral compound. Now, because this is a neutral compound, right, we got a -1 charge for our chlorine. How many chlorines we have? I see 3. 1, 2, 3, right? 3 chlorines. So since I have 3 chlorines, what is going to get me to be my 0? What my iron have to be here? All right, we're going to do some basic math here. All right, it's going to have to be +3, right? So 3, right, minus 3 chlorines is going to equal 0. So this is going to be a neutral compound, like I mentioned before. So since we know, right, that for iron, it's an oxidation state of +3 or charge of +3, then we must put, for iron chloride in the charge here, 1, 2, 3. So this is iron 3 chloride. That's the name of this compound. All right. All right, so now let's look at the second question. All right, hopefully, you guys are doing well. If not, it's okay. We're here to learn. So let's see what y'all know. All right, so what is the name of this chemical formula? What's the name of this chemical formula? You know the drill. Feel free to pause me. If not, let's get to it. So, couple different things we have to notice here, right? PB, what's PB? PB is a transition metal. In this case, it's actually lead. Okay, so this is lead. 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 Looks like lead, but it's lead. Now, so now that you know that this is lead, right? Not lead, lead. Okay. NO2. This is a polyatomic ion. I mentioned to y'all that y'all have to know the polyatomic ions. Go ahead and check out that video. If you don't have it, it's okay. But NO2, right? So NO2 in my mind, I'm thinking, okay, it's not something. Okay, so it's either going to be nitrate or nitrite. That's it. Those are the only choices that we have here. So in this case, we're going to know, right, NO2 is nitrite, right? In this case, nitrate has one more oxygen. So this is nitrite. Bam. Excuse my horrible handwriting. Now, this is lead nitrite. Okay, so we got it basically named, right? We're good? No. If this was your final answer, you are incorrect, okay? So, what do we have to do here now? What do we have to do here, Dr. J? Remember, this is a transition metal. So you got a transition metal, you got to have that Roman numeral. So, here's what we have to do now, right? We got to figure out, well, what is this charge? All right, what's the oxidation state? So for nitrites, that's why you got to know your polyatomic ions, y'all. It's -1. All right, this is how we're always going to determine all of our transition metal oxidation states. We find it through the anion. Okay, so in this case, NO2, you're looking at -1 charge. Now, because I have two NO2s, right? Bam. What am I looking at total? -2 here. And we know that this is a neutral compound, so it has to equal 0, right? Got to equal 0. All right. So, because it has to equal 0, well, what's going to get me to 0? My lead got to be +2. So 2 minus 2, there we go. I know some math there. 0. Okay. So my charge for lead is 2. So my final answer is going to be lead 2, right? So this 2 is telling me the oxidation state of my lead nitrite, which is my polyatomic ion. So hopefully you guys got that one right. If not, we about to move on to the last one. All right, here we go, everybody. This is your last question, right? If you're 1 for 2, if you're 2 for 2, if you're 0 for 2, you got this is your last shot. Your last shot. What's that? You only get one shot. You know what I'm saying? Shout out to Eminem. That Super Bowl was crazy. Now, anywho, Cl2O7. Cl2O7. What are we thinking here? What are we thinking here? How are we going to name this compound? Right? Cl2O7. Couple different things you got to go through your mind here. First is you need to figure out if this is going to be ionic compound or molecular compound. So ionic compounds must remember that it's between a metal and a nonmetal. So is chlorine a metal? No, it's a nonmetal. Is oxygen a metal? No. It's a nonmetal, right? Okay. So now we know that this is going to be a molecular compound, right? Covalent bonds taking place here. So, you know the routine before. If you don't want me to give away the answer, go ahead and pause me. If not, here we go. All right, so now chlorine. oxygen. Those are only two elements. Because it's a molecular compound, we know that we have to name it as a molecular compound. Now, remember, with molecular compounds, we have prefixes that we have to include here. So, because this is a chlorine, right? Chlorine. So I must say dichlorine. D-I-C. You got to spell these things out too. What is that? There we go. Dichlorine. So this is letting me know, right? My molecular compound, I have dichlorine. What about this side here? So remember the second name, right? You're going to change the ending from oxygen to IDE. So we know it's going to be oxide. The question is, what's going to go for the prefix? So if you remember, for the prefixes, they're going to be 7. So 7 is helped. Helped, right? Helped. Helped. Hold on. Helped oxide, all right? So we're looking at helped oxide for our second name here. Okay, so when it comes to molecular compounds, right, prefixes are key. As well as we're going to see it's the same thing here. We're going to keep that first the same, but the second element will be changing to IDE. All right, so very similar to ionic compounds. The only thing you really got to worry about is that we have prefixes here. And if you didn't know 7 was helped, well, you're going to have a hard time in that case. All right, so make sure that you guys know your prefixes. All right, make sure to know your prefixes. So this full compound name is dichlorine helped oxide.